I'm receiving a lot of comments on like soldering techniques, like the best practices on how to apply some of those techniques and what to be careful with while you're basically soldering, especially small devices as well. I think with the through-hole electronic components, people feel pretty confident and comfortable. But basically when it comes to SMD devices and small devices and PCBs that are heavily populated with components, people seem to be struggling a little bit. I want to basically just show you like practical ways of how I do this. Different types of soldering tips, right? Now this is the standard one I use. Basically here the tip, the very top one that I'm showing here on the screen to you is basically about 1 millimeter thick. So this, and it's, as you can see, it's pointed. Some of them actually come like as a knife edge, which is sharp. It's good for cutting things. It's good for like, you know, applying solder to larger surfaces. It's good for especially removing solder from large surfaces as well. Those flat tip ones. But this one I have been using for a long time, and I always prefer this pointed tip because it allows me to get into narrow spaces and gives me much better control over where and how I want the solder to flow. Let me just show you in relation to the PCB. For example, if I was to solder like leads of devices such as these ones, you can see the pitch as like the distance between the two leads on this component, for example, is way narrower than this soldering iron tip. This is where things will start to get tricky, and basically you will struggle controlling over it. The chances are when you're trying to solder something onto one of these pins, you're likely to smear it to the other parts. Ideally, we don't want to deal with it. So the preferred method really is using something which is finer, which I already have here. For example, this is one such tip. Now this one, as you can see immediately, it is actually very pointy, but when you actually compare it to the pitch of the leads, it can actually help me in terms of soldering these finer leads, as you can see. So the pitch or the tip of this is 0.1 millimeter, so it's 1/10 of what I showed to you earlier on. As you can see, there's a huge difference in terms of the control each one of these tips will provide you with. Both of these soldering irons actually come with different features depending on what you are planning to do. Without further ado, let me just take this component. What we're going to do next is try to populate U3. I already have the components here. One word of caution here is on boards like these, when you have basically removed something, or it's basically it's been desoldered previously, you can see there's a lot of residue of like solder that actually gives you a lot of peaks there, which prevents you from placing the component flat onto the surface. So what you want to do before you actually grab your soldering iron is basically just to clean this board a little bit. Let me start with the soldering wick. What I normally do is I also apply additional flux like this one. It makes the flow much easier. What I'm going to do is I'm going to use the 1 millimeter tip here, which should be good enough. So basically what you do is you can also dip the braid there, and then you just apply it. You just heat it up. As you can see, I don't know if you actually are noticing the silver color that is forming right between the braids there. That is actually a good sign because it's actually sucking up the solder that is already on the surface, which is exactly what we want here, right? So we want all of that residual solder moved away from the pad onto the wick itself, right? So you can already see the difference, right? You can start to see the pad shapes clearly, very uniform. You see when I touch the soldering iron tip there, there's still a little bit of solder left, which flowed there. So if you're really picky like me, you can also just go ahead and get rid of those as well while you're at it. Do a better job, like so. This is good. And then we can move to the bottom as well and try to remove that. As you can see, it's basically, you can see the heat application, the effect of the heat right under there. It's like almost boiling there, the solder there when I apply the heat. So as you can see, while I'm basically removing it, I'm also moving the braid. This is something you got to do carefully. Some pads might be too sensitive. So when you actually heat it up and move it like this and apply too much pressure to the pads, you might damage the PCB. Basically, the pads might come off. And that basically causes a much bigger problem before you actually fix your components there. Once you've actually filled it with, filled the braid like with a lot of solder there, it becomes really stiff and thick. So this part we can't really use anymore. So to access the new copper, like the new part of the braid, you just basically clip this piece off and throw it away. So you always end up with like a nice clean braid there, which is ready to go. Even though we have removed the solder, now there's this yellow residue, which is basically what happens when you heat the flux. It's very sticky and it can also carbonize if you apply too much heat to it afterwards. And the way to take care of this really is just using the isopropyl alcohol here. You just basically apply it like I'm showing here to the surface. And I also use like a nylon brush. It's like one of these like really cheap brushes. These ones you can easily get in bulk. I mean, for example, the last packet I got was about like 50 of these. It's just like, it's going to last me for a few years at least. So you can just basically shorten the bristles as well, so they become stiffer. They actually come a bit longer, so they're softer on arrival. But if you really want, like, to roughen it up a little bit, you can just cut these to size, and then it actually works better, as I've found. So I always basically shorten the bristles because they're really long and soft, which doesn't work really well. You basically apply the brush, like, you can be firm with it. You're not going to break it. I always apply like once or twice. If you're happy with the first application, it's usually good. But if not, then don't worry about doing it a few times. But now you can see there's a huge difference. Like, this is what I was trying to tell you. Look how clean it is now. Compare this part to this part. I'm going to place the component here. Keep it perfectly centered like so. And now the tricky part is applying that first connection. I'm going to use the fine tip here. Now what I'm going to do is, typically it's good practice to do the opposite diagonal, which is this pin right there, to give you that mechanical stability. Now that I've got like two pads soldered down, that's perfect. It's not going to move. Then I can just go in line like one after the other one after this. Then it becomes a much easier operation. Now let's say while soldering, you used a very thick soldering iron tip, and this is what happened, right? So you applied too much solder, and everything sort of like made a massive blob there. You ended up connecting everything. All of it is shorted now. So obviously this is not going to work. This is a typical fault that we all see, especially when we first start this. I mean, this is typically what happens. It's very hard to control the solder. We can use solder braid not to remove the entire solder in a location, but we can actually use it to flow some of it. Press on the braid and basically bring it closer to the areas where there's excess solder that we would like to remove. Because the tip already has collected some solder, it's not actually flowing as much. So I'm also going to clip that tip. You don't have to go as a rectangle, but there might be some situations where you really need like almost like a strand of a braid, so to speak, right, while you're doing this. You can also cut this at an angle, like so. to give you this sort of like tip, which helps you with much smaller residues, basically, like, you know, this finer places. I always suggest just use the solder flux, sort of like to enhance it. That's always gonna help you flow more solder in difficult, like challenging areas such as this one. To be sure, you can use your precision soldering iron, right, to get in there and really almost refine it. Now you can see we've got this actually sorted. We have this extra residue, which is like yellow and sticky, like I showed you earlier on. Isopropyl alcohol, and our brush, nylon brush, there waiting for us whenever we need them. But the bottom line is, I have cleared my solder. Now the device is nicely soldered to place.
Subscribe for more tips on circuit making.